Imagine a computer that can solve millions of problems simultaneously. This isn't science fiction, it's the promise of quantum computing. Unlike our classical computers that rely on bits, quantum computers utilize qubits. These qubits operate in a completely different way. Instead of being just a 0 or a 1, a qubit can exist in both states at the same time. This mind-boggling concept forms the foundation of quantum computing. This ability to be in multiple states simultaneously allows quantum computers to tackle problems that would take classical computers billions of years to solve. The implications are vast, spanning fields like medicine, materials science, and artificial intelligence. It's a new paradigm in computation, one that could revolutionize our world. The power of quantum computers stems from two strange quantum phenomena: superposition and entanglement. Superposition allows a qubit to be in multiple states at once. Think of a coin spinning in the air. It's both heads and tails until it lands. Similarly, a qubit can be both 0 and 1 simultaneously. Entanglement is even weirder. Imagine two coins flipping together, always landing on the same side, even if they're miles apart. That's entanglement. Two qubits linked so that knowing the state of one instantly tells you the state of the other, no matter how far apart they are. These bizarre quantum properties could change the world. Imagine designing new medicines by simulating molecules at an atomic level. Quantum computers could accelerate drug discovery and lead to breakthroughs in treating diseases. In finance, they could optimize investment strategies and manage risk more effectively. Quantum computers could also break the encryption that protects our online data. This has sparked a race to develop new, quantum-resistant cryptography. The impact of quantum computing on cybersecurity is a double-edged sword, bringing both challenges and opportunities. Section 4. Quantum realities. While incredibly powerful in theory, quantum computers are still in their early stages. Building them is incredibly difficult. Qubits are notoriously fragile and prone to errors. The technology is advancing rapidly, with companies like Google and IBM making significant strides. However, we're still years away from having stable, large-scale quantum computers. For now, they're best viewed as specialized tools that complement, rather than replace, classical computers. Section 5. The quantum future. The future of computing is undeniably quantum. Stable and scalable quantum computers will revolutionize countless fields. They could help us understand the universe better, develop new materials, and create unprecedented artificial intelligence. The race for quantum supremacy is on, with countries and companies vying for leadership in this transformative technology. The impact of quantum computing on our world will be profound, shaping the future in ways we can only begin to imagine.